In the western Pacific Ocean lies a crescent-shaped scar carved into the Earth's crust. It spans 1,580 miles across the dark ocean floor. To understand the absolute depth of the Challenger Deep, the lowest point in the trench, you have to look upward. If you dropped Mount Everest straight into this abyss, its famous peak would still sit more than a mile entirely underwater. The floor bottoms out at an astonishing 10,984 meters below sea level. This diagram shows the subduction zone responsible for that depth. The dense Pacific plate grinds beneath the smaller Mariana plate. As the heavy crust descends, extreme pressure squeezes out trapped seawater. This melts the mantle, sending magma upward to form the Mariana Islands. The trench acts as a massive geological engine. The crushing weight of tectonic plates constantly recycles the ocean floor and violently builds entirely new island chains on the surface. For most of modern history, scientists looked at those crushing, pitch-black depths and assumed they were a completely lifeless void, totally disconnected from the ecosystems up here in the sunlight. That assumption bred a very specific type of confidence. In 1979, Japan formally proposed using the trench near the northern Mariana Islands as an active disposal site for low-level nuclear waste. This localized diagram highlights their logic. Gravity and tectonic subduction would do the heavy lifting. You drop barrels of radioactive waste into the trench, and the Earth's downward conveyor belt slowly swallows the hazardous material safely deep into the mantle. That plan relied on the assumption that the deep ocean was a silent, empty trash can. It ignored the violent, unpredictable reality of subduction zones, where massive megathrust earthquakes regularly shatter the crust long before any material reaches the mantle. Proving what was actually happening at the bottom required going there.
The first attempt happened in 1875, when the crew of the HMS Challenger mapped the abyss completely blind, simply dropping miles of weighted rope over the side of their ship until it finally hit the mud. It took 85 years to send humans down. In 1960, Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed inside the bathyscaphe Trieste. This descent required massive, blunt force engineering to survive the physics of the abyss. To manage the trip, the Trieste carried a massive float filled with gasoline. Because gasoline is lighter than water, it provided reliable buoyancy, while heavy iron shot was used as ballast to aggressively drag the crew down toward the seafloor. This pressure diagram translates the physical environment they faced at the absolute bottom. The temperature hovered near freezing, and the water column above exerted 1,086 bar of pressure. That equates to 8 tons of crushing force on every single square inch of the sub's hull. Walsh and Piccard touched the bottom and returned intact. Surviving that descent proved that human engineering could successfully operate in the most hostile physical environment on the planet. But the real discovery wasn't the depth. When the crew of the Trieste looked out their thick viewport into the freezing darkness, they saw life moving in the mud. Modern expeditions soon followed, bringing back samples. Researchers found monothelomea, single-celled amoebas thriving in the deep sediment, growing to massive sizes of over 4 inches wide. The sheer pressure and extreme isolation trigger a strange biological response known as deep-sea gigantism. Down here, scavenging crustaceans called amphipods grow vastly larger than their identical cousins living in shallow coastal waters. We found complex vertebrates too. In 2014, cameras captured the translucent Mariana snailfish, holding the record for the deepest living fish ever filmed, actively swimming at more than 80,100 meters down. The existence of these creatures proves that biology can adapt to survive 8 tons of pressure per square inch. They push the absolute physical limits of where life can exist on Earth. In 2019, explorer Victor Vescovo completed a record-breaking dive, taking a modern submersible directly to the absolute floor of the Challenger Deep. Down in the deepest mud on the planet, resting right alongside those highly adapted deep-sea organisms, he found a plastic grocery bag and candy wrappers. The physical trash is accompanied by invisible chemical markers. When marine biologists tested deep-sea amphipods from the trench, every single specimen had synthetic microplastics in its stomach. Their tissues also contained high concentrations of PCBs, a toxic industrial chemical banned in the 1970s.
The biological samples carry an even darker signature. Tissues from these isolated aquatic animals contain elevated levels of carbon-14. This is the direct radioactive fallout generated by Cold War nuclear bomb testing conducted decades ago. These chemical and physical markers confirm a basic rule of physics. Gravity dictates that whatever goes into the water eventually sinks. The deepest point in the ocean catches the heavy fallout of human industry. We spent decades operating under the illusion that extreme depth guaranteed extreme isolation. The atomic isotopes and synthetic plastics sitting 36,000 feet below sea level prove that no part of the planet is safe from surface runoff. The Mariana Trench operates as the absolute floor of a single, continuous, highly connected global system. It is the Earth's ultimate, inescapable sink. Every piece of plastic discarded, every toxic chemical leaked, and every atom split on the surface eventually settles into the dark. On a planet entirely bound by gravity, there is no such place as away.